Can you swap your expensive Elegoo/Anycubic FEP sheet for cheap, generic packaging foil? In this video, I put this dangerous theory to the test. If you're into 3D printing hacks, you need to see what happened. Spoiler, it almost destroyed my printer. The hypothesis: we all know that in the FDM world, you can sometimes use random things like cheap PC sheets or tape for build plates. But in resin printing, the FEP, fluorinated ethylene propylene, or NFEP film is the heart of the printer. It needs to be perfectly non-stick, optically clear, and precisely tensioned. I wanted to see if a cheap resin packaging foil, the kind used to vacuum seal bags, could physically do the job. If you need to change the FEP film on your Elegoo Saturn 4 but don't have any fancy tools like sponges or specialized kits, do not worry. You can absolutely get the job done with just a few basic items that you probably already have lying around. All you really need is a new piece of FEP film, a simple pair of scissors, and the screwdriver or bit set that most likely came with your printer or that you use for other projects. Once the vat is clean, use your screwdriver or the appropriate bit from your set to remove all the screws that hold the frame together. You will encounter different layers of screws, first the ones holding the outer frame, and then a whole set of smaller screws that clamp the two halves of the inner frame together around the old film. Keep these screws organized, perhaps by laying them out on the table in the same pattern you removed them, so you know where they go later. When you have finally separated the two halves of the inner frame and discarded the old, damaged film, it is time to cut your new film. Take your scissors and cut a piece of FEP film that is slightly larger than the frame itself, leaving maybe a centimeter or two of extra material around all sides. You do not need to be perfectly precise here, just make sure it covers the entire opening with some overlap. Now, place one half of the frame down on a flat surface, lay your freshly cut film over it, and then place the other half of the frame on top. Before you start putting screws in, gently press the two halves together with your hands and pull lightly on the edges of the film to remove any major wrinkles. The film should be smooth, but do not stretch it like a drum just yet. Once all the screws are tight, take your scissors and carefully trim away the excess film that sticks out beyond the edges of the frame. Cut as close to the metal or plastic as you can without damaging the frame itself, because any excess material might prevent the frame from sitting properly inside the vat. After trimming, you can reassemble the vat by putting the inner frame back into the outer housing and securing it with the larger screws you removed at the very beginning. The small print, the result: it worked. All components were physically present. The red flag, looking closely at the surface finish, the details were soft. The fine text on the cube was almost unreadable. Why? Because the cheap foil has a different refractive index and scatters the UV light more than a dedicated FEP film. This blurs the LCD light, reducing sharpness. Test 2, the stress test, full build plate, the goal: print multiple models covering the entire build area. The sound: about 30 minutes in, I heard it, a loud thwack thwack thwack. In resin printing, that's the sound of the print sticking too hard to the film. The FEP is supposed to be slick, low surface energy, so the resin releases easily. The cheap foil has high adhesion. The failure: the print was a mess. Support snapped, layers were missing, and large sections of the model were stuck. The disaster, the leak: what happened? During the failed print, the cheap film couldn't handle the mechanical stress. Unlike FEP, which is tough and elastic, the packaging foil is brittle under repeated stress. The result: the film developed microtears and pinholes. Resin seeped through these holes, the danger zone. When I lifted the vat, resin had leaked onto the LCD screen. If resin cures on the screen, it can permanently damage the polarizer or even crack the glass during cleaning. My print. The autopsy: why it failed. Material science: original FEP/NFEP has a non-stick property similar to Teflon, PTFE. The cheap foil, likely polyethylene, does not. Resin chemically bonds to it. Mechanical properties: FEP stretches slightly to release the print, reducing suction force. The packaging foil is rigid and thin. It simply tore under the pressure of the lift cycle. UV transparency. The cheap foil likely blocks or diffuses more UV light than it lets through, leading to undercuring and failed layers. The final verdict: do not do this. While the cheap foil is a fast and ultra-budget alternative to high-performance polymers like FEP, PTFE, or ETFE, it is a dangerous fire hazard for your hardware. What I learned: you should only use genuine PFA, perfluoroalkoxy, or FEP tubing/film specifically designed for 3D printing. If you absolutely must use this cheap stuff, only attempt the tiniest prints with extreme caution. But honestly, don't risk your $300 printer to save $10 on a FEP sheet. It's not worth it,